Hello everyone. Let's begin with the third problem of Bode plot, that is g of s into h of s is equal to 10 into s plus 10 divided by s into s plus 2 into s plus 5. Now comparing this with the standard format, that is 1 plus s into t, rearranging the terms, in the numerator we get 10 into, taking 10 common from this term, it becomes 10 into 1 plus s by 10. Similarly in the denominator, s into, taking 2 common from this term, that is 2 into 1 plus s by 2, and 5 into 1 plus s by 5. So the equation becomes 10 into 1 plus 0.1 s divided by s into 1 plus 0.5 s into 1 plus 0.2 s. Now let's find out the starting point of the graph, that is nothing but the magnitude at origin. So from this equation we can see that the value of k is equal to 10. And also you can see that 10 by s starts at origin. So taking 10 by s with log values, that is 20 log of 10 divided by, taking the value of s which is nothing but j omega as 0.1, we get 20 log 10 minus 20 log 0.1. So wherein this value will give us plus 20 decibel. So just adding 20 log 10 with plus 20, we get 40 decibel. Next we need to find out the slope of the poles and zeros. So let's see the equation here. We can see that there are 3 number of poles and 1 zeros. So first is pole at origin, that is nothing but 1 by s, which starts at 0, and second is simple pole, which is 1 divided by 1 plus s by 2. And you can see that comparing it with the standard format 1 plus s into t, t value will be 1 by 2. As is the first corner frequency, let us take the value of t as t1. Omega c1 will be inversely proportional to t. So hence 1 by 2 becomes 2 radians per second. Next simple pole is 1 divided by 1 plus s by 5. Taking the value of t2 which is equal to 1 by 5, omega c2 will be 5 radians per second. Next a simple 0, that is 1 plus 0.1 s, t3 will be equal to 1 divided by 10, that is nothing but 0.1. So inversely proportional to time is omega c2, so that becomes 10 radians per second. Now that we know the starting magnitude and then the corner frequency, now we need to find out the slope of the equations, that is poles as well as 0. Taking the first pole, that is 1 by s, as this is a pole, the slope will be minus 20 decibel per decade. So as total change in the slope will be also minus 20 decibel per decade. Now let's find out the change in slope with each of the poles and zeros. So first pole is 1 by s, which has slope of minus 20 decibel, as all the poles will have slope of minus 20 decibel and zeros will have plus 20 decibel per decade. So the total change in the slope is minus 20 decibel. And the next pole is 1 divided by 1 plus s by 2, wherein we have already found out the corner frequency. The slope is minus 20 decibel. So we had already minus 20 decibel from the previous pole. Now minus 20 decibel get added up. So the total slope will be minus 40 decibel per decade. Going with the next pole, that is 1 divided by 1 plus s by 5. The corner frequency will remain 5. And then the slope is minus 20 decibel per decade. So already we had minus 40 decibel per decade slope. And then now 20 decibel is getting added up. So totally we have minus 60 decibel per decade. Next is a 0, that is 1 plus 0.1 s, which has a corner frequency of 10. The slope of a 0 is plus 20 decibel per decade. So as we already had minus 60 decibel per decade, plus 20 gets added up. So the total slope will be minus 40 decibel per decade. So if you observe here, I have written the corner frequency in the increasing order, that is 2, 5, 10. Make sure that you do this first. Now let's go with phase plot analysis. So first step is replace s with j omega. So this is the equation. So let's replace on the left hand side. It becomes g of j omega into h of j omega will be equal to 10 into we have 1 plus 0.1 s. So this becomes 1 plus 0.1 j omega. In the denominator we have j omega into 1 plus 0.5 j omega into 1 plus 0.2 j omega. So to find the angle of this, let's first convert this to polar form. The polar form of 10 is 10 at an angle 0, and let's assume that the polar form of the second term is r1 at an angle theta 1, and here r2 at an angle theta 2, and r3 at an angle theta 3, and r4 at an angle theta 4. So the magnitude will get simplified directly, that is 10 r1 divided by r2 into r3 into r4. So the angle will be 0 and then plus theta 1. From the denominator, when it shifts to the numerator, takes negative sign. So it is minus theta 2, minus theta 3 and minus theta 4. So now writing the angle of g of j omega into h of j omega, we get for 10 the angle is 0, and then we have theta 1, that is plus theta 1, which is nothing but tan inverse of y by x. The y term is the coefficient of j, which is nothing but 0.1 omega, and x value is 1. So hence 0.1 omega divided by 1. And similarly, finding the remaining angles, that is minus theta 2, which is tan inverse of omega by 0, as real term is 0, and minus theta 3 becomes tan inverse of 0.5 omega divided by 1, and the last term here is minus tan inverse of 0.2 omega divided by 1. Now let's see this table. This is the table which has the value of omega in radians per second, and then different angles of equations and the resultant angle. So we have taken some random values of omega, that is 0.2, 2, 5, 10. So for 0.2, tan inverse of 0.1 into 0.2 divided by 1 will give you plus 1.14, and similarly minus tan inverse of 0.2 divided by 0 will give 90 degree. Anyhow, the second column will remain minus 90 degree throughout, as it is omega by 0, which is nothing but tan inverse of infinity. And similarly the next term, that is minus tan inverse of 0.5 into 0.2, which is nothing but minus 5.71, and next tan inverse of 0.2 omega, that is 0.2 into 0.2, which is minus 2.29. Adding all of these angles, we get minus 96.85 degree. Now similarly finding the readings with 2, that is plus tan inverse of 0.1 into 0.2, that is plus 11.3 degree, and similarly here it is minus 90 degree, and next minus tan inverse of 0.5 into 2, which gives minus 45 degree, and next minus tan inverse of 0.2 into 2 gives minus 21.8 degree. Adding the total will give you minus 145.85 degree. Similarly finding for the rest too, that is 5 and 10 radians per second, the total resultant angle will be minus 176.62 and minus 187.12. This is the magnitude plot. Let's see how to plot it. So in the first row we can see a pole at origin, that is 1 by s. So before we start, we need to start with the magnitude at origin, that is the starting point of the slope, which is nothing but plus 40 decibel, as we have calculated, that is nothing but 20 log k plus 20 decibel. So right from here we are supposed to draw a minus 20 decibel per decade line until the corner frequency is reached, that is 2. So I draw minus 20 decibel slope until 2. So how do we draw this minus 20 decibel? A line which is parallel to minus 20 decibel per decade slope, that is considering 1 unit in the y-axis and 1 unit in the x-axis. So next is from 2 we have minus 40 decibel per decade until 5. So from 2 minus 40 decibel decade until 5, and next at 5 it is minus 60 decibel per decade. So at 5 I am going to draw a line which is at minus 60 decibel per decade until it reaches 10. So from 10 the slope will be minus 40 decibel per decade. So this is the graph for magnitude plot. This is the phase plot. Now we'll see the first reading, that is at 0.2 we have the reading of resultant angle as minus 96.85. So at 0.2 minus 96.85, and the second reading is at 2, it is minus 145.85. So at 2 it is minus 145.85. At 5 it is minus 176.62, and at 10 we get the reading of minus 187.12. So now joining all of these points we get a graph, that is curve, in the phase plot. The line of 0 decibel in the magnitude plot is here, and exactly it crosses x-axis at this particular point, which is nothing but omega GC. So omega GC is exactly at 4.2 radians per second. Now I'll just extend this line and check what is the phase margin value. The phase margin value will be with respect to 180 degree line. So this is minus 180 degree line. So what is the magnitude from here to here? That is nothing but plus 9 degree. Next, coming to the value of omega phase crossover frequency. So that is at this particular point, that is it crosses the minus 180 degree line. So omega PC is equal to 6. So just extending the line upwards, and then the magnitude of the gain margin is plus 8 decibel. As both the values are positive, the system is stable. Thank you for watching.